Homework 13, section 7.1, the standard normal curve, video 1. So far we've done a lot of descriptive statistics. We've calculated measures of center, mean, median, and mode. We've calculated measures of spread, range, variance, and standard deviation. And we've also calculated measures of position, quartiles, percentiles. We've also drawn a lot of pictures. And we've done some probability involving discrete data. Now, why does that matter? Because we're about to make a big transition. We're about to make the big transition from discrete data to continuous data, and probabilities leading towards inferential statistics, estimating something about a population, testing a claim about a population. So how do we make this big transition? Well, let's start by the transition from histograms to probability density curves. I'll define what a probability density curve is in the next video, but let's review what's happened previously. When we had data, and specifically continuous data, meaning that we can measure it as finely as we wanted to as many decimal places as we want, we created classes. Let's make that past tense. We created classes of a certain class width and built a histogram. So for example, perhaps we had a class width of 1, which means our classes were from 0 to 1. Actually, it would be 0 to, let's say 0.9, 1 to 1.9, 2 to 2.9, or however fine we made the measurements. And our lower limits were on our histogram, and then we raised a bar to represent the frequency of each class. But if your data is continuous, that means you can measure it to as many decimal places as you want. There's no limitation, except by the device with which you're measuring the data. But because the data is continuous, we can make class widths smaller and smaller, as long as the sample size is big enough. In other words, if we only have, 20 data points, then we don't want 30 classes because some of them would be empty. But if we have a really large sample size, such as in the hundreds or even in the thousands, and our data is continuous, then we can make our class widths as small as we want as long as there's enough data to fill in the classes. For example, let's say our class width is 0.2. Then we would get more classes, but the rectangles in the histogram would be thinner. And again, making sure that we have enough in our sample so that the classes all contain some values. So what's going on here? Well, let's revisit polygons for a second. Remember how a polygon worked? You basically connected the midpoints of the tops of each rectangle in the histogram. And you got this jagged looking line. Line segment, line segment, line segment, line segment, line segment, and so on and so forth. But what happens to the polygon as you start getting more and more skinnier classes? It still has corners, if you will, sharp corners every time you connect the dots. But the dots are a lot closer to each other, and there's a lot more of them. And as a consequence of that, when you connect them, you start getting what's called a smoother curve. Yes, it still has its sharp turns like it did right there. But imagine that we did this over and over again by making the class widths narrower and narrower, giving us more points on the tops of the rectangles and a smoother curve. Can we make the class width infinitely small, get an infinite number of thin rectangles so that the points are so close that it makes a smooth curve without any sharp corners? Actually, yes, and the technique that allows us to do that is rooted in calculus. So obviously we're not going to go into the calculus that takes us from a finite number of skinny but not infinitely skinny rectangles to an infinite number of infinitely skinny rectangles. But if you trust me, when the calculus happens, we get a perfectly smooth curve without any sharp corners. What does that curve look like? Well, it looks like exactly what you would think it looks like, a curve with no corners. And that curve is called a probability density curve. In the next video, we'll talk about what that means in terms of probabilities.